welcome back to our channel. Now, I'm going to discuss about the chain rule. So, derivatives of a function using the chain rule. So, when do we use the chain rule? We can use the chain rule when differentiating a function of a function like the f of x or f of g of x. Okay? So, like that. Now, we're going to find the derivatives of this. So, by that is derivatives of g of x multiplied by derivatives of g of x. Okay? Example. Remember, you can use the chain rule when you're differentiating a function of a function. Okay? Like this in general. Now, example. Example number 1. Derivatives of 5 minus 6x to the 5th power. First step, you have to identify the inner function and rewrite the outer function, replacing the inner function by the variable of u. Okay, so the inner function there is the 5 minus 6x. So let's say u is equals to 5 minus 6x. Okay, the outer there is the whole one. Okay, as your f of x. Okay, this is your outer. So this is 5 minus 6x is your u, then raised to the 5th power. Alright, then your g of x is equals to your u. That means 5 minus 6x. Now when you find the derivatives of this and this, the derivatives of f of x is equals to 5, diba? There is a power 5, then u, 5 minus 1 is the 4th power, right? Then how about the g of x? Derivatives of g of x. So 5 minus 6x, 5 is a constant, and this one is a constant multiple rule. So 5 is 0. This one is negative 6 because negative 6 times 1 is negative 6. Now we're going to substitute all the values for your derivatives. Okay? Again, substitute the derivatives and the original expression for the variable u into the chain rule and simplify. Okay, so again, derivatives of 5 minus 6x to the 5th power equals to this one, 5. Your u is 5 minus 6x to the 5th power, and then the derivatives of g of x is negative 6. Then simplify. So 5 times negative 6 this is negative 30. Then multiply by 5 minus 6x to the this is 4. Okay, from here to the 4th power. So this is your answer. Okay, another one. Okay, derivatives of 2x squared minus 4, then cube, or cube of 2x squared minus 4. Okay, let's identify your u. Your inner is 2x squared minus 4, and then your f of x is equals to u, then you have cube here. Then g of x is your 2x squared minus 4. When you find the derivatives of those, so derivatives of f of x is equals to 3u squared. Okay, power rule. Then derivatives of g of x is for the difference rule, but there is the first term is power rule and also multiple constant rule, and this one is a constant. So we have 4x only. Why? So 2 is your constant here. 2 times 2 is 4. Then x will be 2. Your power of your x is 2 minus 1 is 1. So no need to write 1 here. And this one is constant. That means 0. So 4x minus 0 is still 4x. Okay, let's substitute here for your chain rule. So the derivatives of 2x squared minus 4 cubed equals to this one. Okay, 3. Then u is 2x squared minus 4, then squared. Multiply the derivatives of g of x, which is 4x. So the final answer is 12x multiplied by 2x squared minus 4, then squared. Okay. How about if I apply the quotient rule? Okay, example number 3. Derivatives of 2x plus 3 divided by 6 minus x squared, then cube. Okay, let's identify the u. So I will write it. Your u there is 2x plus 3 over 6 minus x squared. Then the f of x is your u cubed. Then I will copy the g of x from your u, 2x plus 3 over 6 minus x squared. Let's find out the derivatives of those. So this is 3u squared, and then derivatives of g of x is, since this one is a quotient, the first one is derivatives of first function, upper or your top. So that is only 2 because this is multiple or constant multiple rule, and this one is constant, so this is 0. So only this one is 2. Then multiply by your second function, so 6 minus x squared. Then minus derivatives of your second function, so which is negative 2x only, because this is a power and this is constant, so 0 minus 2x. Okay, that is negative 2x. Then multiply by your first function, your top number, okay, or numerator, 2x plus 3. Then all over square root of your denominator. Right, so this is your derivatives of g of x. Now let's find out what is your chain rule. So your chain rule here, derivatives of f of x is 3. Then u is 2x plus 3 over 6 minus x squared, then squared. Multiply. So we're going to copy all of this. So that is 2 multiplied by 6 minus x squared, then minus negative 2x multiplied by 2x plus 3, then square root of 6 minus x squared. Let's simplify, okay? So we have to copy the first, and this one will be 2 times 6 is 12 minus 2x squared. Then this is negative, then negative, so that is positive, then distribute property. So plus 4x squared plus 6x all over 6 minus x squared, then squared, or square root of 6 minus x squared. Okay, then combine like terms of your numerator here, but this one we're going to copy. So we have, okay, so negative 2x plus 4x squared is 2x squared, then plus 6x plus 12 over square root of 6 minus x squared. Alright, so this is our answer. Okay, so this is our last example. So derivatives of square root of x cubed minus 7. Right? Or we can write as x cubed minus 7 to the 1/2. Okay, raised to 1/2. So the radical or the square root is when you write in the exponent, that is fractional. Okay, 2 is the index, okay, and then the 1 is the exponents of your inside of the radical. Okay, since this one is, there's no exponent, that means only 1, okay, so that's how you rewrite as a fractional exponent from the radical expression. So next, so let's find out what is the inner. So your u there is x cubed minus 7. So the f of x is equals to u raised to 1/2. That's 1/2. Then your g of x, that means your u, is x cubed minus 7. Then second step, take the derivatives of each function. So derivatives of f of x is equals to, so power rule, 1/2 of u raised to, so we're going to subtract by 1, 1/2 minus 1, that is negative 1/2. And then this one is derivatives of g of x, that is power rule again. So that's 3x squared only. So this is constant. Then let's substitute the value or the chain rule. So derivatives of f of x, so that is 1/2 multiplied by the u is x cubed minus 7 raised to negative 1/2. Right? Multiplied by derivatives of g of x, which is 3x squared, then simplify. So this is the whole one, so that means that is your numerator. Then this one, as you can see, that's negative. We're going to apply the negative exponent, turns to fraction. Okay, and then your exponent will be positive on your denominator. So you have 2 here. Then this one is x cubed minus 7 raised to 1/2, or you can write as a radical, so 2 square root of x cubed minus 7. Okay, that's it. Alright, so this is your derivatives of this function. Okay, again, first step natin is we identify the inner function and rewrite the outer function, replacing the inner function by the variable of u. So this is your inner, then the outer is this one, then the inner is your g of x. So then after that, you take the derivatives function, so that is derivatives of f of x and g of x. And third, you substitute the value or the derivatives and the original expression for the variable u into the chain rule and simplify so that you can get the final answer. So I hope you understand this. Is this the chain rule or derivatives of chain rule using of this? Remember when you apply the chain rule, when you see the function is when you see the example or the given is differentiating a function of a function. Okay. Now, and then, you can apply those rules like yung power rule, product rule, and quotient rule. Alright?